Hello everyone. So in the previous lecture we have understood how to take transpose of a matrix. Now let's begin the process of identifying inverse of a matrix. The very first step makes us to learn the difference between transpose of a matrix and inverse of a matrix. Because while we are taking transpose of a matrix, it is always derivable. That means given a matrix A, if the elements are A11, A12, A21 and A22, and if you are asked to identify the transpose of a matrix, you will simply convert the rows into columns and columns into rows. So the result will be A11, A12 while you are turning the first row into a column, and the second row is A21 and A22, right? So that's how you get the transpose of a matrix. And as I'm saying that transpose of a matrix is always derivable. Okay, transpose of a matrix is always derivable. So then there is a difference between taking transpose of a matrix and between identifying inverse of a matrix, because inverse of a matrix, this procedure requires to fulfill at first a necessary condition, and that necessary condition says that the given matrix has to be a square matrix. Okay, given matrix has to be a square matrix. And if we find that the given matrix is square matrix, that is not enough to identify the inverse of a matrix, because the sufficient condition also needs to be fulfilled. And the sufficient condition shows or tells us that the determinant of the given matrix has to be non-zero or non-singular in nature. So according to the sufficient condition, given a matrix, the determinant of that matrix has to be non-zero or non-singular in nature when if we are trying to identify the inverse of a matrix. Okay, so that means the first one we can easily understand from the given matrix, the necessary condition, if it is equal to A11, A12, A21 and A22, we will simply calculate the number of rows and number of columns. So here it's a 2 by 2 matrix, as there are two rows and two columns, and definitely as the number of rows and number of columns are equal to each other, so we can consider it as a square matrix, because we know that that is the condition of a square matrix, right? That is the condition for a matrix to be square matrix. So it's a 2 by 2 matrix and it can be regarded as a square matrix. But then only the necessary condition has been fulfilled over here, right? The necessary condition has been fulfilled. But even then, if it is possible that we cannot identify the inverse of a matrix if the sufficient condition is not fulfilled. In order to check for the sufficient condition, we need to know how to identify the determinant of a matrix. Okay, now the determinant of a matrix actually asks us to follow our formula. So given a matrix A is equal to A11, A12, A21 and A22, if we are asked to identify the determinant of this matrix, we will write it like this. And then the formula is, we have to take the product of the elements of the principal diagonal. So this is the principal diagonal as we know, and the product of the principal diagonal basically means the product or the multiplication of the elements of the principal diagonal. So that is basically a11 into a22 minus the product of the elements of the off principal diagonal, or the multiplication of the elements of off principal diagonal, which is a12 into a21. And that's how we can identify the determinant of a matrix. Remember, there is a minus sign which is by the formula. So taking the multiplication of the principal diagonal minus the minus the product of the elements of the off principal diagonal, which will provide you with the determinant. Now if, let's say, this determinant value is not equal to 0, then it's non singular in nature. Okay, non-zero means non-singular, and only then we can identify the inverse of a matrix. So if this condition is satisfied, inverse of a matrix is possible. However, if the determinant of A is simply equal to 0, that means it is singular in nature and sufficient condition is not fulfilled, and in that case we cannot identify the inverse of a matrix. Okay, so that's why it is important to fulfill both the necessary and the sufficient condition to get an inverse of a matrix. Here I have shown you only a 2 by 2 matrix example. Now let's take some more examples of identifying a determinant. Let's take another 2 by 2 example. Okay, over where A is equal to 6, 4, 7, 9. Question is whether we can identify the inverse of a matrix. So it is beforehand basically. Instead of performing all the operations, beforehand you are judging whether you can identify the inverse of a matrix or not, just by looking at this matrix and by identifying whether it's a square matrix or not, and by identifying its determinant value. Okay, so over here it's a 2 by 2 matrix, which represents that it's a square matrix and the necessary condition is fulfilled. In order to fulfill the sufficient condition, we are checking for the determinant value, which is 6 into 9 minus 7 into 4, and we get 54 minus 28. The result is 26, which is not equal to 0. That means the determinant is non-singular in nature and matrix inversion is possible, right? Again, I have shown you a 2 by 2 example. Now let's take a 3 by 3 case. So this is an example of a matrix which has got 3 rows and 3 columns. So 8, 3, 2, 6, 4, 7, and 5, 1, 3. Given this matrix, we can identify that this is a 3 by 3 matrix. Now, when it's a 3 by 3 matrix, we cannot just simply apply the formula like product of the elements of principal diagonal minus product of the elements of the off principal diagonal. Rather, there is a technique of identifying determinant of a 3 by 3 matrix. In that case, by formula, we will consider that the first row, that means this particular row elements, we will assume a plus sign before this particular element, a minus sign here, and plus sign here. This is the specified formula to identify the determinant of a 3 by 3 matrix. By formula, we for the first row only, we are taking a plus value for the first element, negative value for the uh, second element of first row, and positive value for the third element of first row. Okay, and then what do? We consider the A11. Let's say this is A11, which is 8. So we take 8 and we know that it has got a plus sign. So we are not putting the plus sign over here. Now the element that we are considering, just make that particular column and that particular row out of the calculation and take the other four elements that is left, 4, 7, 1 and 3. Then come to the next element of first row, which is minus 3. Now why you are considering minus 3? You are not considering that particular row and that particular column. Rather, you are taking 6, 7, 5, and 3 in the box. So 6, 7, 5, 3. That's how you form it. And lastly, plus 2. So when you're taking plus 2, the first row, third column is out, and you are left with 6, 4, 5, and 1. So write it down here, 6, 4, 5, and 1. So please keep the steps in your mind. It's a 3 by 3 matrix. At first you have checked and found that this is a square matrix. Then you are trying to identify determinant. You are only putting emphasis on the first row. The first row, first element is a positive one. First row, second element is a negative value, and the first row, third element is a positive value. Again, this is by rule. And then the element that you are taking, you are omitting that row and that column and taking the other four values, and that's how we have formed all these individuals. Okay, now it's time to calculate. Now for this, again we will use the previous concept, product of the elements of the principal diagonal minus product of the elements of the off principal diagonal. So basically now we will do 4 into 3 minus 1 into 7. That's how we have formed this. Let's do it for the next one. So we will get 6 into 3 minus 5 into 7. And then we have got 2 over here and multiply. I'm sorry, it should not be this sign. And I will multiply here 6 into 1 minus 5 into 4. Okay, so this is equal to then um, this is equal to 12 minus 7 minus 18 minus how much, 35 Okay, and then we have 2 here and 6 minus 20, right? 6 minus 20. Let me rewrite this portion again. This is 2 into 6 minus 20. Okay, so ultimately we are left with 8 into 5, because 12 minus 7 is 5, so we are just multiplying it. Then we have a negative 3, so this negative 3 into negative 17, and then this 2 into negative 14. Okay, if you're confused, what you can do over here is you can also keep this separate. Okay, and write it as 8 into 5, so you can keep 5 in bracket. Okay, so yes, 12 minus 7 is 5, 18 minus 35 is negative 17, and 6 minus 20 is negative 14. So 8 into 5 minus 3 into negative 17 plus 2 into negative 14. So ultimately, what do we get? We get a value for the first one is 40. Then for the second one, negative negative becomes plus 51, and for the last one it is negative 28, which is equal to 91 minus 28, which is equal to 63. It is not equal to 0. That means it is non-singular in nature and can identify, we can identify the inverse of a matrix. Okay, so that's how a 3 by 3 matrix's determinant is identified, and then we can decide whether the inverse of a matrix is possible or not. Okay, before going into the further steps of identifying the matrix inversion methods steps, let's look at the determinant properties or the properties of determinant in next lecture video.